Welcome, welcome. Here for one more video lesson here in Mr. Nice's Math Analysis and Trig classroom. Today we are going to be talking about the parent functions. Okay, the parent functions. Some people call them mother functions. Okay, so the parent functions. We have 9 of them that we discuss in our course, and they start from the very beginning. Y equals a constant. Okay, and that could be a 3, it could be a 5, a 7, a 9, a -2. It does not matter. Okay, the bottom line is the graph is simply the graph of a horizontal line at C. The domain, whoops, I need arrows in both directions, is all real numbers, and the range is simply just the C value, whatever that C value happens to be. And I'll put my attempt at squiggly brackets around there. Okay, that is one parent function, y equals constant. I'm going to try to go in order here. Then we have the linear function, right? Like y equals x. We all know what that looks like, I hope. Okay, I missed my axis arrow over here, so throw it on there. Y equals x. Totally missed that one. Y equals x needs to go through the origin. Boy, I'm not too good at that one here. Let me cheat and use the line tool. There and there. Y equals x. Much easier on the board to do that, but it is what it is. Domain, all real numbers. It goes left and right forever. Range, all real numbers. Okay, so there are 2 functions. Well, we have the linear, we also have the quadratic function. So on the quadratic, we all know what that looks like as well. The parent graph is y equals x squared. It looks just like a parabola because it is a parabola. Domain, all real numbers. Range. Now be careful, the range is only the numbers from 0 and above, so it includes 0. Of course, you can never include infinity. This covers only quadrants 1 and 2, whereas this graph is in quadrants 1 and 3. We're talking parent graphs only here right now. A 4th graph is y equals x cubed, right? Our cubic parent. Now we know what that looks like because that has a triple root at 0, unlike this which had a double root at 0. So we have a nice little hitchy poo coming through here. There it is. I'll write my domain in quadrant 2. All real numbers, and my range, this guy goes left and right forever. Also, all real numbers. So that's where we stop as far as degrees go on here. So that's 4 parent functions right now, and then we'll jump down to the square root function. Okay, the square root function, if you think about it, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So this thing goes out quicker than it goes up, so our graph looks like half of a parabola. Domain starts at 0 and goes to the right forever. The range also starts at 0 and goes up forever. However, going up slower than it goes over. That is 5 graphs. We now have y equals the log of x, which will be a new function for you guys this year. The log graph we will certainly be discussing more throughout the year. The log graph is very similar to the square root graph, but it crosses here at 1, so it actually comes on down through here and runs along the y-axis. It looks very similar to a square root, but notice it's not crossing at the origin, it's crossing at 1, 0. Domain, now it does not include 0, but it does go on to the right forever. This is called an asymptote along here. It runs along the axis. My range, notice it goes on forever. I don't need that parenthesis there. It is simply all real numbers. Okay, so we are up to 6. Let's look at a 7th one here, and we'll call that 3 to the x, and really this can be any number at all. I just chose 3. Okay, so this one is very similar to the log graph, only in a flipped manner. We'll talk about how that is affecting anything. Think about it. 3 to the 0. Anything to the 0 power is 1. 3 to the negative first power, that's like 1 over 3, so that'd be 1/3. 3 to the negative second power is 1 over 3 squared, so that'd be 1/9. So on the negative side, it's really small. It's hovering along the axis. But now when x is 1, I'm 3. When x is 2, I'm 9. When x is 3, I'm 27. So this thing goes up quicker than it goes over. Okay, it's increasing extremely quickly here in quadrant 4. I'll write the domain. Domain goes left and right forever. The range, however, it does not touch 0, so parentheses, and goes on upward forever to infinity there. Okay, so that's the range from 0 to infinity. Okay, so that is 7 parent graphs. Let's look at an 8th one here. The 8th one is what we call the reciprocal function. The reciprocal function looks like this, right? If I put negatives in, like -2, I'm going to get -1/2. -3, I get -1/3. So again, it's hugging the axis here, but if I put in like -1/2, the reciprocal will be -2. If I put in -1/3, the reciprocal will be -3. -1/4, we get -4, so on and so forth. Same thing happens on the positive side in quadrant 1. The domain, well, left forever and right forever, but in between it misses something, so it's all real numbers not equal to 0. The range, if I'm going from bottom to top, it's got everything, 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 but it runs along here. Top to bottom, everything, 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 but it runs along here, so again, all reals not equal to 0. And our 9th and final parent graph is the absolute value of x. The absolute value of x when I'm dealing with positive numbers is just y equals x. Boom. But when I'm dealing with negative numbers, I put a -2 and I get +2. It gives me the opposite of x, so it's y equals -x. Okay, so this is really the graph of y equals x when x is 0 to infinity, and this is the graph of y equals -x when x is -infinity to 0. Okay, so this is what's called a piecewise function. That's something you'll talk about a lot in calculus if you move on to calculus either at the high school or college level. Okay, the domain is all real numbers. It covers everything left to right, but the range, we know the output is only positives and 0. The output is non-negative. Okay, so those are our parent graphs, and those are the domains and ranges of the parent graphs. Hope you enjoyed your quick little lesson on parent graphs. Catch you on the flip side.